Hello, folks. Thanks for joining me even remotely here for Maths Without Mistakes. I'm Dan Meyer. I'm the Director of Research at Desmos, where we're trying to help students learn maths and love learning maths. And this is probably my most, sensational, clickbaity title I've ever offered here. It seems to promise to you folks that we'll find a way to prevent your students from ever having any bad marks on their exams or assignments. And that's not what this is about. This is instead an invitation for us to rethink about the thing that we often call mistakes and brainstorm more productive strategies for working with student thinking. And so I just want to say, first of all, as a discipline, we have done a lot to rethink the idea of getting wrong answers as being bad or shameful. Like you can find posters all over the place. Mistakes allow thinking to happen, for instance, is one common idea. Let me see. And there's others like mistakes are expected, inspected, and respected. And in some posters in some classes, they are also corrected. And so there's more here. This is good because if you go to Google and you Google for why am I bad at, and then one of those subjects right there, Google will return results to you that kind of are like an oracle of sorts for the world's anxieties. People don't just type in terms into Google they want to search for, but also they type in their deepest, darkest secrets and fears sometimes. Why am I bad at? And then, so which of these subjects do you imagine has the highest and the lowest number of search results for why am I bad at X, Y, or Z? You can open up a private browser window and try this yourself. The results will be similar, and they are mind-blowing to me. I expected this, but did not expect the magnitudes to be so stark that there were single-digit searches for those other subjects, and meanwhile, math had tens of thousands. And it's worth us thinking about, like, why is that? What happens in our instruction of mathematics? So I love the posters. I'm glad we are rethinking what wrong answers mean and whether they're shameful or not. That's super important. But there's a few issues with that approach I want to just address briefly here. One is that our pedagogy carries far more weight with students than whatever posters we have on the wall. The Pathway to Equitable Math Instruction folks call this out really well when they say that practices don't often align or don't always align to the phrases, the messages that students receive about mistakes. Another is, I just want to propose this to you, is that we misdiagnose student thinking that is wrong. We misdiagnose it as mistaken far too often, and that constrains the set of possibilities we have for response and changes our relationship with our students, I think, in negative ways. That isn't a mistake. Like what we often say, hey, it's cool, that was a mistake. It's all right, it wasn't a mistake. We shouldn't call it a mistake. I think of that mistakes are like heffalumps. I'm not sure if you folks are familiar with the tales of Winnie the Pooh. This is high literature in my house right now. Winnie the Pooh. Piglet came over for a slumber party and slept in a dresser drawer right there. It's not very hospitable of Pooh, but there it is. Anyway, Pooh starts snoring. Piglet hears it and gets very alarmed by this sound, which Piglet does not trace to Pooh at the moment. Instead, Piglet gets all up in Piglet's own head and starts to imagine a heffalump. This sound derives from a heffalump, this evil bee/elephant type creature. And Piglet is very worried about what to do with the heffalump. And the fact of the matter is it's not a heffalump. And the right approach here is not to say to Piglet, hey, it's cool, heffalumps are okay. Heffalumps are not a big deal. That right there doesn't address what's actually going on. It misdiagnoses the situation and constrains Piglet's possible responses. While Piglet is perhaps, gearing up for battle with the heffalump, what Piglet ought to be doing is, fetching Pooh some kind of nasal strip or a CPAP machine, or telling Pooh to stop eating so much honey before bedtime. Come on, that kind of thing. That wasn't a mistake. That wasn't a heffalump. We need to figure out what's actually going on here. I don't want you to think of me as, I'm out here on the West Coast of the United States. I don't want you to think of me as some kind of, hippie, some kind of radical here saying like, oh, well, students are always correct. Let them lead us. That's not what I'm saying. Wrong answers are real. We ask questions and there are wrong answers to questions oftentimes. What I am trying to say is that the number of times that wrong answers are mistakes made by a student is in fact a lot smaller than we often think and tell students. And in fact, only the student can diagnose their thinking, their wrong answer, as a mistake. Far too often, these are very, very purposeful thoughts students have And we need to engage with them more seriously than just to say, that's okay, we expected this, we'll inspect this, we'll correct it, and move on. It's not a big deal. We need to take them much more seriously. And to help us, help you folks, I think, feel what that's like to make wrong answers, to answer incorrectly in ways that are not mistaken and in fact are extremely thoughtful and even brilliant. I would love to send you into a Desmos activity. That activity is at this class code right here, student.desmos.com. You type that code in right there, PDJ, VEJ, and that's going to drop you into an activity. And since this is a recording, you're going to have to find your way in this activity. But what I'd like you to do is to head to screen 3 right here, where I'm going to ask you, let's see, screen 2, I'm going to ask you about some widgets. I'm going to ask you, is this a widget or is this not a widget? Let's see here. I'll show you a slide that maybe presents this in a little bit more tractable manner. Yeah, right here, widget or not a widget. You folks probably have never heard of a widget. This is the first time you've seen this shape. That's fine. Your answers will likely be wrong early on. I'm going to share with you one shape and ask you, is this a widget or not a widget? And then I'll tell you, it's a widget or not. You are right or you are wrong. And you'll do that for a few more. And then I'll share with you some results. I'm going to ask you, like, what do you think a widget is at this point? So at this point in the video, I'll ask you to pause the video and to do this work yourself. And then come on back when you're ready with that explanation written in. Pause time. And we're back. Check this out right here. So on this screen, first of all, I want to call this out. Love what I'm seeing. I saw, like, for instance, people were very wrong early on and even wronger on the second widget question. And then slowly got some ideas. And on that fourth one, wow, a lot of confidence. I really love that right there. I snapshotted some responses of what people were saying about widgets. Some people are saying, I still have no idea. We'll come back to those in a little bit. What I definitely want to say here, though, is that though you folks were very wrong on this second question about a widget or not a widget, none of you, and I mean this, none of you, I have no way of knowing if you were mistaken. And I'm guessing very few of you were. That in fact, your brain, you are operating out of your best current understanding, which you've developed very sincerely, very earnestly through hard work, and you're just acting on that as best as you can. And for me to say, oh, that's a mistake, but that's okay. It's a mistake. I'll help you with the right answer. Does nothing to acknowledge the sense that you were making, the sense you had made about this situation. It does nothing to use that as an asset to build on for me in my instruction. Just calling that, dismissing your thinking, your wrong answer as a mistake, actually limits my possibilities, both in relationship to you and to help your learning. Some quotes from people that speak to this that I love right here. For instance, one second, right there. Amanda Jansen, who wrote the book Rough Draft Math, which I highly recommend, says that she assumes that whatever someone is sharing makes sense to them right now. I just love that. And not trying to think about fixing it, correcting it, making it right, but just like get it out of your head and try to put yourself in the person who thought that. What were they thinking? What makes sense to them right now? A colleague of mine, Bethany Lockhart Johnson, read this quote and said to me, like, wow, that might really change my marriage right there. Like, this is good for human to human relationships, even outside of math classes. This is how learning and life work. Rochelle Gutierrez talks about how conceptions make sense until something no longer works. Rochelle Gutierrez, Dr. Gutierrez, talks about how there aren't even misconceptions aren't a real thing in Gutierrez's framework here. Students just have ideas, and it is on us to offer experiences that help students define the limits of those ideas and develop new ones. Or the Pathway to Equitable Math Instruction links this idea of mistakes, and particularly equating them with wrongness, rather than treating them with opportunities, that represents a tendency towards perfectionism and even paternalism, a tendency that has echoes and currents throughout history, where certain people come to a new place and then say, hey, the way you're doing this is all wrong because it's not like how we would do it, versus understanding what they're up to. Let's not reproduce that. I also want to just call out that this idea of mistakes and misconceptions, the prefix there, mis, refers to something that is deviant or poorly formed. And I just want to suggest to you folks that, like, that is we only can say that they are deviant when they deviate from something. And in this case, we're referring to our own ideas. When we say this is a mistake or a misconception, what we mean is you're not thinking the way I'm thinking. And to which the student should rightly feel like, yeah, no joke. That's how I think. I'm not like trying to get inside your head and mimic your thoughts. I'm offering you my thoughts. And we should treat those thoughts as a gift and as a resource. And all this talk about mistakes has the effect, I think, of dismissing those resources and gifts. Students instead, they have takes. They have conceptions, not mistakes and misconceptions. I want to suggest that the same is true about something as small as widgets, that you're just developing your ideas, and there were nothing about what you thought was mistaken, though many of you were wrong. It's true about small things like widgets, and true about large things, large ideas, like, for instance, love. Like, I've been wrong about love every day of my life, including today. Like, for instance, as a small child, as a baby, like, I think love is, whoever is feeding me, like keeping me alive. I'm a small kid, and love is like whoever I spend my time with. I'm an adolescent, a teenager, and I think that love is this, my biochemistry getting out of control when I'm around somebody. It's like, oh, this must be love. And, every single time I'm wrong, but I'm never mistaken. I'm operating out of the limits of my knowledge with a lot of sincerity. You get married and that changes your idea about love. You bury a loved one and suddenly you have love. Love is something you can feel for someone who is no longer living or has a physical body. You get involved with other people through, adoptive relationships or through foster care or any of those sorts of things. And love, you have love for people who are not related to you, who are very different from you. Love just changes and changes. You're never wrong about it. You're never mistaken about it, though you are wrong. Your ideas are incomplete about it. So if you buy that and you see how student ideas are such a precious thing, and we can discourage students from offering them in their sincerity. If it's true for widgets, small stuff, and love, big stuff, why would it not be true about math class? Again, I want to offer you that wrong answers, rather than being treated as mistakes or deviant, we have other options. We can treat them as very useful or very interesting. And in fact, I think I've seen some very brilliant wrong answers, and students deserve to know when their wrong answers are brilliant answers. So I want to just offer implications of this if we start taking student thinking very seriously, to the point that this is a valuable thing. I will not dismiss it as a mistake or try to overwrite it with my own knowledge, but instead I want to understand it and work with it. I have a few ways I can offer you to how you can work with wrong answers that reorient your classes away from the idea of, was this a mistake? Were you mistaken? To how can we develop your ideas? So for one I love to do is to start with student senses. Student senses are never mistaken. They're sometimes wrong, if you misperceive something or make an incorrect conclusion about them, but they're not mistaken. I'm just telling you what my eyes see, buddy. I'm just telling you what I'm interpreting and sensing about the world. It's like when you make fun of someone for mispronouncing a word, that's not cool, because they learned to pronounce that word by reading it. They saw it with their eyes. They didn't hear it from someone, most likely. And their brain said, well, I've seen other words that look like this, whose sound I know. Let's just try this out for a pronunciation. And it's wrong. And it's wrong, but it's worth calling out that they came to that through their senses. It was not a mistake. Or, for instance, in math class, this is why I love with even questions like this, right here, is this a widget? Is a question that operates on a sensory level. Excuse me. Just cut this part out. Fast forward past this part, okay? Or in an investigation of parabolas or quadratics, I want to offer students this path of a basketball and just ask them, what's your best guess? Does this ball go in or out? Many people will be wrong here, but none of them will be mistaken. Or here's some dapper cats and some not dapper cats. And I'm curious, students, what do you notice about the dapper cats that's not true about the not dapper cats, and vice versa? What's your definition of a dapper cat? That's right here. Students are just drawing from their eyes and what they're seeing. And some might say, well, The bows look strange on the not dapper cats, and that's just their senses speaking to them through their mind. And that is like, I cannot call that a mistake. It's like very helpful, very valuable, very useful. Others might use words like proportional, or words that are not that level of formality, but say things like, well, as the cat gets bigger, the bow tie gets bigger as well. That's all super valuable. Or to say right here, like if we were to share with you this, and I can ask students, after how many cups do you think the cooler will run out of water? A question that relies on the student's visual sense of the water in the jug as it reduces there, as it empties out. So asking students about their senses as an entrance into mathematical investigation gets me out of the mentality of, is this right? Is this wrong? Is it a mistake? Is it not? What do I do? Over to, is this useful or is this not? How is this useful for all of us? What is the student thinking about right now? So that's one thought here. Another is to ask explicitly for wrong answers. If you're the sort of teacher who feels somewhat panicked when students give you wrong answers in a classroom discussion, like, what do I do with this wrong answer? I know it's wrong. How do I handle this? I feel you. I love to just ask straight up for wrong answers. Some students who have a hard time even like guessing because they've been so burned by math class where the expectation has been around rightness and correctness, they'll offer a wrong answer. I had one student who, when I asked him for, okay, so what does a wrong answer look like, Jeff? I could see Jeff visibly unclench, and it's like, as if to say like, oh, wrong answers. I'm great at wrong answers. Let me offer some. So for instance, I might ask students right here, instead of, or in addition to, after how many cups do you think the cooler will run out of water, to ask instead, okay, same question, but wrong answers only. And it's so useful to see students say like 0 cups is going to be wrong, or negative cups is wrong, or 1,000,000 cups is wrong. Super, super useful. And that helps me decenter my own thinking and instead inquire about a student's thinking. Like the inquiry-based learning I love most is the one where the teacher inquires very fervently with a lot of persistence into what students are thinking. Others here, let me see. Yeah, to make sure when you see a wrong answer, rather than addressing like what is mistaken about it in your mind, like how it does not conform to what you were thinking, instead just to name what's right in the world name what's right about that student's answer. So for instance, let's see here. What could be fun here? I love this W.W. Sawyer quote, in which Sawyer says, like the master teacher, the center of the art of teaching is to discover what is correct about student thoughts. Or Megan Franke, a professor of math education at UCLA, has this fantastic idea here. When you mark student work, so often you know what happens. They crumpled up and throw that into the bin after seeing the mark at the top, the score at the top. Instead, that's effort, spent and lost on your part. Something you might do is take one assignment and just try this out. Instead of marking it for right or wrong, mark it for what's interesting about that work and see what that does to you, your perception of students as a discipline, and what it does to students if they linger on your quote unquote marks a little bit longer. Give that a shot. Lisa Jilk runs video clubs where teachers will examine student work in a class, and the frame that Jilk uses with teachers as they examine video is not like, was the student correct or not, or what did the teacher do even, but what did students do or say that was mathematically smart. Love that. So naming what's right about a student's wrong answer, very effective for helping that student think through their own thinking, but also to take that wrong answer and say, in a different world, like what would be true about a different world where this was right, is also super valuable. So for instance, right here, here's a question that we ask students about this water cup, and forgive me for the ounces here, but we say like, okay, so with 0 cups filled, here's the ounces in the water cooler. Okay, after 1 cup, here it is. 2 cups, here it is. After 3 cups, I believe we're talking about 616. Okay. A real joy about my work at Desmos as director of research is that I get to like dip into this question, which is in our curriculum, and thousands of students have answered it. and to just look at all their thinking and to be surprised by the wrong answers and how smart they are. And that has radicalized me more than anything about student thinking and its value. So I would encourage you to think for a second, to pause the video in a moment and think, what is the most common wrong answer for 10 cups? And like A, why is it smart? And B, how would the question here have to change so that it was in fact the right answer? Two important questions. Go ahead and pause this. Come on back in a second. Okay, we're back. So I'm sure there's lots of fantastic answers from you folks on this one, some of which are wrong, but all of them are very smart and interesting in my view. I'll tell you that most common wrong answer here by a long shot is 608. And so it's super possible to name what is right about this, which is to say the student has kept this pattern going, subtracting 8 ounces for every cup and subtract the 8 ounces there. And so that's one important thing to do is say, oh, this is right. There's something very smart about this. And a question you can ask students who got the answer right, perhaps, or as a whole class discussion, a valuable question to ask here is to say, how would this question have to change right here? Like, what would you have to change about the whole scenario so that was the right answer? I'll give you a second to think about that. And it becomes clear to me that like this would be right if the pattern went 4 and then 5. This would be correct. And for me to say, so like again, I have options here. When I see that wrong answer, 608, I can say, oh, the student was mistaken. I'll tell the student you're mistaken. That's okay. We expected that, inspected that, respected that, correct, and we'll correct that. Or I can say, oh, wow, this is so interesting. I love this. Check this out. This is not right. But in a different world, this would be right. And to ask the class, like, think about this right here. This, like, what would have to change about the world, this problem space here, for that to be the correct answer? Change anything so that that's correct. And their responses then communicate value to the student who is wrong in ways that go way above and beyond any posters I might have on the walls of the room. And they also like give students who had the answer correct something more to think about that develops their learning. Does both of those things. Super valuable in my thinking here. Love that. So others here. I love the idea of coming up with a third answer, one that is better than any of ours to date. So this comes from Amanda Jansen, who says that she loves to take 2 answers, neither of which are complete, neither of which is mistaken, both of which may be wrong, and to say, like, what do we learn from both? Can we make another answer that's we like even more? And so, like, I'll invite you right here to look at our activity. You folks might have gone ahead, which I can't prevent you from doing that, given this recorded state here. But I might, in this moment, say, like, okay, there's people that are saying these things right here. For instance, I still have no idea. I'm honestly unsure what a widget is. And some people are saying like, okay, a shape with exactly one claw and exactly one eye. Someone else is saying an empty shape with exactly one claw and exactly one eye. These are all super valuable responses here in my view. I can put those up and say, okay, folks, what do a widget figure with an eye and a tail? Given the responses that you have seen here, have these helped you come up with a third answer? And on the subsequent screen, you might see your previous answer dropped in to the next screen, where I'm going to ask you right here to evaluate, not these ones, my ideas. But yeah, your previous answer will show up right here. So I'm going to encourage you on this next screen to evaluate a few more widgets given your new knowledge, and to offer a new prediction, what is your current definition of what a widget is in that blank. So we've taken answers that were all incomplete. None of them were complete. All of them were wrong in a way, and to ask you to develop a new one. Go ahead and pause it, and then come on back once you've given your final answer. Over to you folks. Okay, so I love this right here. These right here, check this out. This is what I mean, is that we have a shape with exactly one claw and exactly one eye, and then a widget is an empty shape. This right here, these are the same people. This is the same person before and after. Before their experience of seeing other people's responses, and then after. Or these right here, look at this right here. This is, again, the same person who has added in this bit about the enclosed shape does not have other markings on it. If I look at your responses on this screen, I see like, wow, people really got this next round. They were just rocking and rolling, doing great. Everyone just got nailed on number 7 there, where people weren't sure what to make of. They kind of thought it didn't matter what was inside the shape, perhaps. We're very wrong with that. And then 100% of people were correct on that final shape. That right there is the development of your conceptual ideas about widgets. Same for love and same for mathematics. None of your ideas were mistaken, though many of them were wrong. There was rightness in all of it, however incomplete it might have been. And it's on me as the educator here to offer you experiences that reveal the limits of your current ideas about widgets. And the same is true again for love and for mathematics. I love that. That was really helpful to see. Thank you. I want to just offer you like the difference in perception from the student who hears you say, hey, it's okay, you made a mistake, to this is really interesting. It's like feel that difference. Try to feel that for yourself as I'm, putting a lot of love on your responses to the widgets, however wrong they were. This is really interesting. Students will perceive that very differently. One feels quite valuable. The other communicates the value of the teacher's thinking less than the students. I don't think that there are thoughtless errors. Rather, errors are full of thought. And it's up to us as the educators to discover and inquire after that thought, use that as a resource, both for student learning in math and also for our relationship with that student. This right here, this poster, I think, is incorrect. I wouldn't call this poster about mistakes a mistake. I can't judge the person's intent in making it, what they're trying to do. But this is wrong. Mistakes don't allow thinking to happen. Mistakes, in fact, are thinking, Herb. I'm not great with acronyms, but you get the point here. Like mistakes, I don't know if a student's wrong answer was a mistake or not. Only they can judge that. And they aren't the thing that then later allows students to start thinking mathematically. Wrong answers, in fact, do represent so much mathematical thinking so much of the time. I'll close with a few ideas here. One from Lisa Jilk, who said, everyone is mathematically smart as a result of living in the world. Just like students, before they arrive at their first year of school, they know so many words. They are linguistically smart for having lived in the world, a world that showers them in sounds and language and spoken word and written word. Similarly, they are mathematically smart because the world is just showering them in numbers and patterns and quantities and growth. And so it's up to us to understand that brilliance and to celebrate it and then develop it. Jared Comfrey thinks of this in a very, the utility of student thinking, where students are our most underutilized resource in school by her telling, meaning that the ideas students bring into class, right or wrong, none mistaken, let's say, that they're all resources that when I get from students their current thoughts, I can use those to build some deeper understanding of the mathematics. And if I were just to come into class and say, okay, here's what I think about the math, and when you're wrong, to say, that's okay, you were wrong. But to not inquire about their thinking, I lose that resource. It's like if my only goal here, if I care nothing for a student's sense of identity and agency in math class, if I didn't care about that, I just cared about a student's cognitive development, it would be important for me to stop using words like mistake, to retrain my mind and instead think about what is so valuable and brilliant and interesting even about these wrong answers. To invite that, to celebrate that, and develop it. I hope you folks have seen in this session so far the value of wrong answers, how they're interesting, how so rarely are they mistaken. And I also want to call out that it's super helpful to have a curriculum or use activities. We're building some at Desmos where there are opportunities to be right and wrong in different interesting ways. Oftentimes, there's opportunities to be right and wrong that aren't different, or they aren't interesting. Like on a multiple choice exam, oftentimes it's like, well, you were right or you were wrong, and the wrong answers don't reveal much of the interesting thought that was bubbling around for students while they made the answers that they made. I want to offer again that there aren't mistakes or misconceptions, none that we outside of the student's head can judge, that students just have takes and just have conceptions. These right here have been my ideas about ideas. And though I think in a year's time, in a day's time, perhaps, I will come to believe that many of them were wrong, I will not say that any of them were mistaken. They were just me trying to operate with my best current understanding, my current conception of how students learn math and come to love learning math. Thank you folks for joining me in this brief recorded session. It's a real honor to be with you folks, even remotely, asynchronously. Please get in touch on Twitter or drop me an email with your thoughts and response, your questions. I would love to hear from you folks. Take care, everybody.